All right, so now we're going to continue with polynomials, and we're going to look at what the zeros of the polynomials are and how we're going to find those zeros. Okay, so when I ask you what is the zero of a polynomial, it's going to be very similar to what we've done with quadratic functions. So when I ask you for the zeros, it is asking you for your x-intercepts. And we do have multiple vocabulary words that we can use, and so instead of just finding the zeros, I can say find the x-intercepts, I can find the solutions. You can say find the roots. So all of these just mean the zeros. So when I ask you what are the zeros of a polynomial, I am asking you if you were to graph that, what would the x-intercepts be? Okay, so the way we are going to find your zeros, make sure when we set up an equation, we want the equation set equal to 0. So if it is not already set equal to 0, we do need to move everything to one side. And then once we set it equal to 0, we're going to solve. Okay, so looking at when we're solving, we are going to be factoring. And always remember, when you are factoring, look for a GCF first. So if they have something in common, go ahead and take out that GCF first. So we're going to set the equation equal to 0. We're going to solve it using factoring, make sure to take out the GCF, and then that's how we're going to get those zeros. Okay, so looking at the first example, if I have x to the third minus 2x squared minus 15x equals 0. First thing I want to look at, notice they all have that x in common, so I am going to go ahead and take that out. And that leaves me with x squared minus 2x minus 15. Okay, so now I'm going to finish solving these to find that 0, or the zeros, so I'm going to factor this out. So now I'm just looking what I have right here, so I'm going to factor this out. So remember, I'm looking for two things that multiply to give me a negative 15. And those same two numbers have to add to give me a negative 2. So when I look at those two numbers, what that's going to be a negative 5. Right? Yep. A negative 5 and a negative 3. Sorry, positive 3. Had a little problems there. Okay, so looking at this one, if I put in my numbers right here, I took out an x, greatest common factor, so that leaves me with x squared minus 2x minus 15. So two things that multiply to give me negative 15 and add to give me that negative 2. So that means it's a negative 5 and a positive 3. Okay, so those are my factors. So now remember, when I am setting those up, I'm going to set each one equal to 0 to solve it. So if I set this equal to 0, that just gives me 0. I'm going to set this one equal to 0. And that's going to give me a positive 5. And then I'm going to set that one equal to 0, and that's going to give me a negative 3. Okay, so looking at those, that would be those three solutions. So I can also double check. So let's type this into my calculator. So I have x to the third minus 2x squared minus 15x. Whoops, that's not what I want. Okay, so let's try that again. X to the third, make sure I get out of my exponent. So if I look at my graph, okay, so we're going to see those zeros. Okay, so remember, your zeros are your x-intercepts. So there's my negative 3, there's my 0, and there's my positive 5. So looking at that one, that's a good way to double check on your graph. Remember, I could also go second graph and pull up my table, and those zeros should be on that y side. So when y is 0, that's going to tell me one of my solutions. So that's the negative 3. There's the 0, and if I go down to 5, it should also be a 0. Okay, so that's a good way to double check in your calculator to make sure you have those correct. All right, let's try the next one. So looking at this, again, greatest common factor, they are both divisible by 2. And then also, I can take out the smallest of those variables, so that would be y to the third. So if I take out a 2y to the third, that's going to leave me with y squared minus 9. So now I have to finish factoring this out. So the 2y to the third is just brought down. Remember, this is a difference of squares. So that means I'm just going to square root both of these. So the square root of y squared would just be y. And then the square root of 9 is 3. So I'm going to have a plus 3 and a minus 3. So that's my factored form right here. So now I'm going to set each one of these equal to 0 and solve it. So when I do that, if I set this equal to 0, I would divide by 2, which is still 0. Cube root, it's still 0, so that's going to give me 0. This, when I solve it, it's going to give me a -3. That one would be a +3. So those would be my zeros of that polynomial function. All right, last one, same concept. Again, take out a greatest common factor first. So all of these are divisible by 4. And then for the variable, remember you take out the smallest one. So 4a squared would be my greatest common factor. So that's going to leave me with a squared minus 4a and then plus 4. So that leaves me with that trinomial. So now we're going to see if it works with that slide and divide. So I'm looking for two things that multiply to give me a +4, and then they're going to add to give me a -4. So when I look at that, those numbers would be a -2 and a -2. So I would have a -2 and a -2. So that would be my factored form. Okay, so if I set each one of these equal to 0, again here, that's just going to give me 0. Both of these are going to give me a +2, so I only have to write it once. You don't have to write it twice. Okay, so if I'm asking you to find the zeros of a polynomial, all I'm asking you for are the x-intercepts. So you are going to factor these and then set each factor equal to 0, and you would get those x-intercepts. All right, so now we're going to kind of work backwards. So here I found my x-intercepts. Now we're going to write an equation if I give you those x-intercepts. So now we're going to kind of flip it. So looking at this one, you're going to write it in factored form first. So looking at the factored form, that's what we did first. So here we got it down to factored form, and then we solved it. So we want to write it in this factored form, which would be look like right here with the parentheses. Okay, so I'm going to write it in factored form first. And then after you do that, you plug in your x and your y if they gave you your y-intercept. So sometimes they give you your y-intercept, sometimes they don't. It's fine. But we're going to plug in your x and your y so that we can solve for a. So we're going to find a by doing that. Okay, so we're got two of these examples. So looking at this, these are my solutions. I have -2, +1, +3. So I'm going to take these solutions and I'm going to write it in factored form. So looking at this, you need to remember, like right here, when I solved these in factored form, so if I set that equal to 0 and I solved it, I moved the 5 over and that gave me a +5. So that -5 became a +5 for my answer. Same thing right here, that +3 became a -3 for my answer. So when I'm writing it in factored form, when I write this, I'm starting off y equals, I don't know my a value, but here I'm going to start writing these in factored form. So this would be x plus 2, because I'm going to take the opposite of that. This one would be x minus 1. This would be x minus 3. So that is one thing to be careful of. When you're writing the equation, make sure you're taking your zeros and you're putting them in the opposite when you put them in that factored form. Okay, so this will be my factored form. Now I have my y-intercept, so I know this is my x and my y. So I'm going to plug these numbers in. So instead of y equals, I'm going to plug in a 12. I don't know a, that's what I'm solving for. Your x is 0. So for all of these x's, I'm going to plug in a 0. And then this is what we're simplifying. So when I look at this, 0 plus 2 is 2. 0 minus 1 is -1. 0 minus 3 is -3. So I'm still going to simplify this. 2 times -1 is -2. -2 times -3 is a +6. So all of that simplified down to 6a. So now finish solving for a, so I'm going to divide by 6 over here. So I know a equals 2. So all of that just to find your a value. As always, make sure we actually write our equation. Okay, and we're writing it in factored form. So we're just going to keep it in factored form, and we just found out our a value to be 2. So all of these are going to stay in that factored form. So that would be my equation. So looking at the next one, same concept. Again, be careful right here when I start writing my equation. In that factored form, I'm going to do the opposite. So this would be x minus 3, x plus 2, and x minus 5. So make sure you take the opposite of those solutions. Then we're going to take that y-intercept they gave us, and we're going to plug it in for x and y. So y would be negative 6, and then all of those x's I'm plugging in 0. Okay. So if I start to simplify that, that's going to be negative 3 times 2, which is negative 6. Negative 6 times negative 5 is a positive 30. So that would all simplify down to 30. So here, if I divide by 30, you're going to get a negative 1/5. So that would be my a value. Don't forget, I need to actually write the equation. So that would be y equals the negative 1/5, and then I'm writing it in factored form. So I am just leaving that part as the factored form. So that would be how I write that equation. All right, next concept, multiplicity. So looking at this, one thing when we're looking at when we solve some of these, so just kind of like what we did up here, notice that we had 2 of the factors that were the same. That means this has a multiplicity of 2 because I had to write it out twice. Okay, so looking at this, multiplicity just means something is going to be repeating. Okay, that factor is going to happen more than once. So the same factor happens more than once. So we can identify the multiplicity on some of these. So looking at this, the first ones we're going to do are some equations, and then we are going to look at a graph. So something that's going to help us out, it's going to have even multiplicity. I'm going to abbreviate. If, when you graph it, it just touches the x-axis. So the even multiplicity, if it touches the x-axis, which means it's going to like bounce off of the x-axis. It's going to go in a different direction, so that means it's going to curve at the x-axis. That means you would have an even multiplicity, which means it would repeat itself. Okay? You would have an odd multiplicity, which means it would just be a 1. It didn't repeat if it actually crosses at the x-axis. So not that it goes in a different direction. So like right here, if I'm saying it goes in a different direction, that means it would go back up right there. So right here, that would have even multiplicity at that point because it bounced off of that x-axis, okay? Here, it would have odd because this one, it's just crossing through the x-axis. It's not turning in a different direction. So make sure you understand the difference between those because we're going to look at that in a second at a graph, okay? So we're going to find the zeros, which means we're going to set them equal to 0 and solve it, and then we're going to identify the multiplicities of each. So looking at this, I'm setting this equal to 0 and solving it. I have to take out a greatest common factor, which would be the x squared. That leaves me with x squared minus 2x minus 8. And then I'm going to finish factoring this out. So 2 things that multiply to give me a negative 8 and add to give me a negative 2. So when I'm looking at that, 2 things that multiply give me negative 8 and add to give me a negative 2 would be a negative 4 and positive 2. So this would be x minus 4, and this would be x plus 2. And then I'm going to solve this. So remember, this is the factored form. I now have to solve it, which means I have to set each one of these equal to 0 and solve it. So x squared equals 0, so that would just be 0. This one, if I set that equal to 0, that gives me a positive 4. This would give me a negative 2. So those are my zeros. That's the same thing that we did earlier in the lesson. So now looking at these, if I ask you for the multiplicity of that, looking at this, notice this is an x squared. So that means technically if I break that down when I did the square root, that means there were 2 of those. So that means this 0 has a multiplicity of 2 because of the x squared. Okay, both of these, they did not repeat. They're only one answer right there. So these both have a multiplicity of just 1. Okay, but because of that x squared, that breaks down with that square root, you technically have 2 of those because x squared would be x times x. It repeated itself. So that means that 0 would have a multiplicity of 2. Okay, let's try the next one. So we're going to factor it out. So greatest common factor would be 3x squared. So that leaves me with x squared minus 1. And then remember, as I'm solving this, looking at that, these are a difference of squares right here. So that turns into x plus 1 and x minus 1. Okay, if I start to solve this, set each one equal to 0, this gives me 0. That gives me a -1. That gives me a +1. So those are my zeros. And then if I ask you for the multiplicity, again, because this is an x squared, remember, technically that's x times x. That means it's repeated. So that 0 has a multiplicity of 2. Both the -1 and +1 just have a multiplicity of 1 because they did not repeat. The x squared, that's technically x. That's what repeated right there that got me the 0. Okay, so multiplicity, again, just means that those are going to repeat. Those zeros are repeating. Okay, so we're going to use that concept. If I give you a graph, we are going to be able to write the equation of the graph. So very similar to what we did here. I just gave you the zeros instead of the graph. Here you're going to identify those zeros on the graph, and then we're going to write our equation just like we did here. Okay, but this time it is asking us for standard form. So that means when I write standard form, you have to write it all out, not factored form. That means I'm going to have to multiply everything together. Okay, so looking at this one, the first thing I need to do is identify the points. So I know I have my zeros at those 3 points. So I know my zeros are at -2, -1, and +1. Okay, so looking at that, I know my zeros. I know my y-intercept is right up here at 0, 4. So realize this is very similar to the one that we already did. They just didn't give us all the information. Here we had to find it. Okay, so I have my x-intercepts, I have my y-intercepts, so now I can go ahead and write it in factored form. The one thing you're going to have to be careful about here, so I'm going to write it up here. When I'm writing it in factored form, so remember this is going to be x plus 2, this would be x plus 1, this would be x minus 1, because I want the opposite of that. The thing you have to be careful about, remember when we talked about the multiplicity, okay? We talked about the multiplicity. That means it's going to repeat. So right here, if it just goes through, you're good. So that just means that's just one solution. But it's going to be an even multiplicity if it curves on that x-axis. So right here, when I am looking at these, this one goes right through the x-axis, we're good. That one goes through the x-axis, we're good. But this one is the one that bounces off of that x-axis. That means that point right there has a multiplicity of 2. That means when I'm writing it, I would have to write that one out again, because that means it's another factor. It repeated itself. So that's the one thing you have to be careful about right here. When you're looking at a graph, we're good, we're good. This one, it bounces off and goes in a different direction. That means it has a multiplicity of 2. So that means when I'm looking at this solution, I have to write that factored form twice. Now, this is all of the work, okay? So realize I'm having to multiply all these together. Looking at this, I do have right here the y-intercept that I can go ahead and plug in. All right, so because I have all of the values right here that I can plug in for that x and y, I can go ahead and plug that in. So my y value is 4. And then remember, my x value is 0. So I'm going to go ahead and plug these in. And then we're simplifying all this. So right here, that's a 2, 1, -1, -1. So I'm multiplying all these together. So 2 times 1 is 2, times a -1 is -2, times another negative is a +2. So that tells me my a value is 2. Now, the hard part here, it asked it for standard form, okay? So I know this is my a value. That was the easy part. The standard form means I have to multiply all of this out, okay? So that means I'm just multiplying 2 at a time. So remember, we're doing the FOIL or the box method. I'm going to use another sheet of paper because we are having to multiply this out to get it in standard form. So I'm going to take the first 2 and multiply those. So I'm doing x times x, x times 1, and then I'm multiplying the 2 out. So that's going to be 2x plus 2. So this first one should give me x squared plus 3x plus 2. Okay, that's those first 2. Now I have to multiply this answer times x minus 1. So remember, we could do the box method too. So I'm kind of doing both ways so you can get a good review. Oops, I'm gonna have to add another box. So that's gonna be x squared, 3x, and 2. So multiplying this using the box method, this gives me x to the third, negative x squared, 3x squared, negative 3x, 2x, and negative 1. Okay, so remember, the reason I'm doing this, even though I just found my a value, on the front, it asked for factored form. So we were good, we didn't have to simplify anything. Here, it's asking for standard form. That means you have to multiply all of your factors out. Okay, don't forget here, like terms. So this gives me x to the third. When I combine those, I get 2x squared. Combine those, I get negative x minus 2. So that was that one. So now I have one more. Remember, I have one more to multiply it by. So now I have to take this and multiply it by the x minus 1. So here I'll do the FOIL method. Again, when you're doing this, you can do any of the method, either one that you want to. So I'm taking the x and distributing it. So that's going to give me x to the fourth plus 2x to the third minus x squared minus 2x. And then I'm taking a negative 1 and distributing that out. So that's going to give me negative x to the third, negative 2x squared, positive x, and positive 2. So that is a lot of multiplication. We're going to combine all those like terms. So looking at this, I only have 1x to the fourth. The third, I have 2 and a negative 1, gives me a positive 1. X squared, I have negative 1 and negative 2, give me negative 3. And then for the x, I have negative 2 and a positive 1 gives me negative 1. And then I have that constant. So that would be what I get in standard form. So now looking at this, remember my a value that I found was 2. That's what goes in the front. So I just sat here and multiplied all these together. Now I have a 2 in the front of that, which means I am now going to multiply all of that by 2, that a value. So when I write my answer, my equation would be y equals, and I'm going to multiply and distribute the 2 out. So this would be 2x to the fourth plus 2x to the third. And then here, when I multiply that, that's going to give me a negative 6x squared, 2 times negative x, and then 2 times 2. So that would be standard form of that polynomial graph. Okay, so that was a lot. Looking at this, we have to multiply all this out using the FOIL box method. You're still finding that a value just like you did on the front side. The thing to be careful about here is if that curves on your x-axis and bounces in the different direction, that is a multiplicity of 2. That tells you you have to write that twice when you're doing that. Okay? All right, last little part of these polynomial functions, we're going to use our calculator. So looking at this, we're going to find relative max and min. So relative max and min, it just means it's not the highest, it's just a high point. Because with these polynomial graphs, remember, you have a lot of curves that are going in different directions. So looking at this, we're going to do this in our calculator, and we're going to find those relative min and maxes. So we're going to go to y equals and put your equation in y equals. So whatever function you have, you're putting that into y equals. And then what we're going to do is we're going to hit second trace. And we are going to hit either the max or the min. So we'll do both because we're finding both. Okay. The biggest point is after you hit second trace max or second trace min, whatever one you're doing, you do have to choose 2 points on either side, on both sides of that max. Okay, so again, we're going to do this in our calculator. So I'm going to go to y equals, and I'm going to type in my function, negative 2 x to the third minus 8x squared plus 2x plus 8. Okay, and I'm going to hit graph just to make sure we can see the graph. So there's my graph. So now I'm going to hit second trace, and I'm going to find the minimum first just because it's the first one. So I'm going to go to number 3 and find that minimum. So now remember, minimum is the lowest point. So I'm going to use my arrow, and I'm going to hit enter on this side because that gives me 1 point. Actually, I want left bound. So we don't want that one. So let's see. I think the way, so we're going to clear it out. So we're going to go second trace again. The one thing I messed up on it's asking me, looking at this, which one, sorry, I'm going to rewrite this. All right, so the thing that I did wrong, so make sure again that we're going to hit graph, we're going to hit second trace, and we're going to do our minimum, so number 3. It says left bound. You always want to start on the left side of your graph. So when I start doing this, I'm going to get my arrow on the left side. So you see my little dot right there, I'm going to hit enter, and then I'm going to go over to the right and get another point over there. So until I see that cursor, there's the other point, so I'm going to hit enter. And then it says guess, you're going to hit enter again. It's going to find that minimum point down there. So that relative minimum would be at about negative 2.79. And then the y value is negative 16.42. So that would be a relative minimum. So I know looking at this graph, it's going like this. Okay, so looking at that, that tells me that's a minimum point over there. So now I'm going to go second trace again, but this time I'm going to find the maximum. So I'm going to hit number 4. Again, I know this is a maximum point over here, so I'm going to get that cursor up here. And I just want 1 point on this side of the maximum, so I'm going to hit enter. I'm going to go over to get 1 point on that side. Hit enter. And then so it tells me there is the relative maximum. So that maximum would be at about 0.12. And then that minimum, or sorry, the y value is about 8.12. So that would be a relative max and a relative min. So again, you hit second trace, and if it's a minimum, it's number 3. If it's a maximum, it's number 4. And then you just have to identify points on either side of that maximum and then either side of that minimum, and it'll find them for you. Okay? So that's all calculator. That's really just a little part of this lesson. Remember, the main part of this lesson is that you can identify the zeros, you can find the zeros, which means you're just finding your x-intercepts. Those are your solutions, those are your roots, they call your zeros. So we factored out using the slide and divide method and factoring out that greatest common factor. So make sure we can find those zeros, and then make sure we can work backwards from those zeros to write our equations either in factored form or in standard form. So remember, standard form is going to be the one that has a lot of work to it, where you're having to multiply out using that FOIL or that box method.